हेलो फ्रेंड्स, वेलकम टू माय चैनल। मैं हूं आपका दोस्त महेश कुमार। और आइए स्टार्ट करते हैं क्वेश्चन रिलेटेड टू हाइड्रोस्टैटिक फोर्सेस ऑन सरफेसेस। फ्रेंड्स, क्वेश्चन स्टार्ट करने से पहले मैं आप लोगों से रिक्वेस्ट करना चाहूँगा कि प्लीज़ मेरे वीडियो को लाइक कीजिए, कमेंट कीजिए एंड मेरे चैनल को सब्सक्राइब कीजिए आने वाले नेक्स्ट वीडियोज़ के लिए। सो फ्रेंड्स, आइए स्टार्ट करते हैं क्वेश्चन। सो क्वेश्चन इज: A square aperture in the vertical side of a tank has one diagonal vertical and is completely covered by a plain plate hinged along one of the upper side of the aperture. The diagonal of the aperture are 2 meter long and the tank contain a liquid of specific gravity 1.15. The center of aperture is 1.5 meter below the free surface. Calculate the thrust exerted on the plate by the liquid and position of its center of pressure. Friends, it is saying that a square aperture is there in the vertical side of a tank. See, this is the tank. This is the tank, and here one aperture is there. This is the at this point aperture is there. Aperture, what happened? A square aperture is in the vertical side of a tank, has one diagonal vertical and is completely covered by the plain plate. It means, friends, it is saying that one diagonal is aperture. It means, friends, the aperture is something like this. This is the square. This is the square. If you see like this is the this is the square. We tilt like this so that this diagonal will come vertical. So this is the one diagonal, it is coming as a vertical. Like this aperture is there and it is hinged from top along the upper side of the aperture. So it is hinged at this point, top point. It has hinged. This point it has hinged. It is saying that the diagonal of the aperture are 2 meter long. The diagonal of the aperture is 2 meter long, 2 meter long, and the tank contains a liquid of specific gravity. इसमें क्या है फ्रेंड्स, जो लिक्विड है इट्स स्पेसिफिक ग्रेविटी इक्वल टू 1.15. 1.15. The center of aperture is 1.5 meter below the free surface. Okay friends, it means, friends, if this is the center, this is the center, this center is 1.5 meter. This is the free surface of the liquid, free surface of liquid. So from here to this center is equal to 1.5 meter. Okay friends, so it is denoting as a h bar, because h bar is the center of the aperture to free surface. So h bar it has given 1.5 meter and specific gravity has given. So from here we will calculate the density rho equal to 1.15 into 1000 equal to 1150 kg per meter cube. So density calculated from here and h bar calculated here. Now we have to find the area. Why we have to find area, friends? Because it is asking that we have to calculate the thrust exerted on the plate. The thrust, or you can say force exerted, F equal to rho g a into h bar. So from here h bar we are getting, rho already get it from here. G value is equal to 9.81. So only pending point is this A. This is the area, and this area is area of aperture. Area of aperture. Now we know that, friends, the area of this is square when diagonal value has given. It means, friends, this is 2 meter and this is also 2 meter. So area is equal to what? 1/2 into diagonal 1 into diagonal 2, or we can say, friends, or we can say The area is equal to what? 1 by 2 into 2 into 2. It means 2 meter square area will come. So from friends, from here the thrust we are able to calculate, because density we know that 1150 into G equal to 9.81 into area is equal to 2 meter already calculated into h bar is equal to this 1.5 meter given. So its value will come, friends. Its value will come. How much it will come? Is 1150 into 9.81 into 2 into 1.5. So it will come 33844.5 Newton. So this is the force exerted. This is the force exerted on the aperture. 334 33844.5 Newton. Now friends, what other point we have to calculate here? We have to find position of its center of pressure. Position of its center of pressure we have to find. So this is the diagram, friends. This is the diagram. This is the tank. Already we explained. This is the aperture. This point is hinged square aperture. This is a diagonal 2 meter and side 2 meter, and this point is hinged from the center point to this free surface is 1.5 meter, and specific gravity is equal to 1.11. So its density is equal to 1150 kg per meter cube. Already explained. Okay, friends. Now we have to find what is the center of pressure. So center of pressure is just below the center of gravity. Suppose this is the center of pressure. This is CG. This is the G point. So somewhere here it will come center of pressure. So this point is H star. This is the center of pressure value. Okay, friends. Now how to calculate this one? How we will calculate, friends? For center of pressure, H, for center of pressure, friends, H star, we know that since it is a vertical case, so the value will come H bar plus Ig upon A into H bar. This H bar value we are knowing how much? 1.5 meter. Area we already calculated 2 meter. Area we already calculated here 2 meter. From here, this is the area and this is the H bar. Okay, friends. Now Ig is the moment of inertia about Cg. So friends, we have to find the moment of inertia of this aperture. So friends, how we will calculate this one? Let's suppose what we will do, we will divide into two triangle shape. We will divide two triangle shape. One triangle is A C B and second triangle is A D C. Okay, friends. First triangle is A B C, this triangle, and second triangle is A D C, this triangle. We will divide separate, then we will add. Now friends, what we will do, we will calculate the moment of inertia of triangle about this base. Base. It means, friends, first you see here, if this is a triangle A B C, this is the triangle A B C. If this is a triangle, and we have to calculate the moment of inertia. So suppose this is the height, H, and this is the width here B, and this is the center of gravity G point. So from here, this distance equal to what? This distance is equal to 2h by 3, and this distance is equal to h by 3. Now if you calculate the moment of inertia Ig at Cg, center of gravity, if you calculate this moment of inertia about center of gravity, it will come bd bdq by 36. This d is equal to h is equal to d, or you can say bhq divided by 36. This is about Cg. Now we have to calculate this moment of inertia about this base. So Ig at base, why we are calculating, friends? I will explain. So first we have to calculate this moment of inertia about base. It is coming, friends, it is equal to bdq by 12. So if you are taking here at Cg, it will be bhq by 36. And if you calculate this moment of inertia of triangle about base, it is coming bhq by 12. Okay, friends? Because why we are calculating at the base? Because this triangle we have to calculate about base, and this triangle we have to calculate about base, in this base AC, and we will add, so we can get the moment of inertia of this diagonal, or you can say square aperture. Okay, friends? Now see here, for this triangle, triangle ABC, moment of inertia Ig about base, equal to how much? B, this is the B into height h cube by 12. Friends, from here you see this is 2 meter, BD is 2 meter, so half equal to 1 meter, and here this base is equal to 2 meter, it means, friends, from here friends, B equal to 2 meter and h equal to 1 meter. So from here, friends, Ig value is equal to what? 2 into 1 ka cube divided by 12 equal to 1 by 6 meter to the power 4 it will come. Similarly, friends, the lower part, for lower part also, the same thing is there. This is the B and this is the height. So same it will come, friends. For lower part also, if you see, for lower part, this is the AC into D. For this triangle also, if you take moment of inertia about base AC, how much it will come? This is 2 meter and this is 1 meter. Okay, friends? So it will come 2 meter into BH cube by 12 is equal to 1 by 6 meter to the power 4. So we will add this one, friends. We will add, then we will get the total moment of inertia. Now, total moment of inertia is equal to what, friends? Total moment of inertia Ig of this is square aperture is equal to what? Ig ABC about triangle ABC about base plus Ig triangle ADC about base AC. Okay, friends, about base AC. Now we will add this one, friends. How much it will come? This is 1 by 3 plus this is also, this is 1 by 6. This is equivalent to 1 by 6. This also 1 by 6. So it will come 1 by 6. So it will come 2 by 6 is equal to 1 by 3. So moment of inertia about, we can say, this AC is the center. Moment of inertia, if you see the total body of a square body, so this is the CG point. So that's why we are calculating this base. So if you take a square aperture, so moment of inertia about AC is equal to what? 1/3 meter to the power 4. Okay friends, now we have to calculate the center of pressure. Center of pressure is equal to what friends? Center of pressure is equal to H star is equal to H bar plus Ig upon E H bar for vertical case. For vertical case. Now friends, H bar already calculated here. H bar is equal to how much? 1.5 it has given. 1.5 plus Ig we already calculated 1 by 3. Ig already calculated 1 by 3 plus area is equal to 2 meter. From here you see H bar is equal to 1.5 and area is equal to 2 meter. Okay friends, so from here 2 into 1.5. So if you calculate here, how much it will come? 1 divided by 3 divided by 2 into 1.5. So how much it is coming? 1.5 plus 0.111. So it will come plus 1.5. Friends, it will come 1.611 meter. Okay friends, this is the H star value. So friends, from here you see the value of H star equal to 1.6, or you can say 611. It will 1.611 it will come. Okay friends, so फ्रेंड्स एक्सप्लेनेशन अच्छा लगे प्लीज लाइक कीजिए, कमेंट कीजिए, सब्सक्राइब कीजिए, दोस्तों के साथ शेयर कीजिए फ्रेंड्स. थैंक यू.